Mm. Mm. Mm.
So we can start, huh?
Can I start now? Yeah, oh, yes, I think
Uh,
it's hard here. A little bit.
so I'm going to start the webinar now.
I need to look presentable. Remove the jacket. No, I need to look presentable. Remove the jacket to help with these. I need to look present formal.
Senele, are you getting?
Wait,
Are you
sorry.
are you getting me?
Yes, I get you. Let me
I'm
take
going
off
to
my
start.
jacket.
Okay.
It's getting hot in Tanzania, bro.
Yeah, I have the ice in my
I don't
room.
know how you guys survive here.
I'm starting now.
Okay, start.
Good morning, everybody. Sanele, can you please stop sharing your microphone? Once again, good morning, good afternoon, good evening, everybody from wherever you are following and watching us. Before starting the webinar, before starting introducing everything, I would like to give 2 more minutes for some participants to join, and then we will start the webinar. Thank you very much. All right. Now we have enough people in the room. My name is Salim. I'm the event manager at the Africa Solar Industry Association. We are hosting this showcase webinar with Huawei, where we will talk about the microgrid solution for mining. Before introducing my speaker of the day, I would like to remind some housekeeping rule. The recording and the deck will be shared after the presentation, and we highly advise you to use the chat for networking and the Q&A for questions. Right, I have two amazing, well-packed experienced speakers with me. I will start introducing Masunda Jaluka Jele, who is Huawei Digital Power Sub-Saharan African Solution Architect. Jele has more than 10 years of experience in electrical and energy sector, including nearly 4 years of direct experience in solar PV and renewable energy. He has previously worked with multiple corporate companies across the solar and renewable energy sector, and he also held a BA in electrical engineering from the University of Johannesburg and a project management certificate. With me, I also have Henry Janele Dlamini, who is Huawei Digital Power Solution Sub-Saharan Africa Senior Products Manager. Henry has more than 12 years of experience in solar and renewable energy. He has also previously worked with multiple corporate companies across the solar and renewable energy. He has an operation management qualification from the University of Cape Town, along with additional certificates. Now that we are going to dive deep to today's showcase entitled Huawei FusionSolar Mining plus Microgrid Solution, I'm very pleased to hold and give back the speech to Henry Sanele to deliver this amazing presentation. So Sanele, I let you do your thing. Thank you very much. You can now share your screen.
Richard, can you see it? Salim and the
can
guys?
we can perfectly see it.
Okay. Thank you, guys. Thank you for joining this session today. I know it's been long called for. Salim has been coordinating with us at Huawei to actually come up with a date. Eventually, we came up with a date. So today we're here. Okay. So today I'm going to be talking about the mining solution. What do we do at Huawei? And also the market, probably. What in the market we're actually doing in the mining sector. So luckily, I'm the solution manager from Huawei. I think Salim has introduced me. I look after utilities, but lately I've been actually visiting a lot of mines, and even in Tanzania, I've been also visiting a lot of mine. If you go into the Mwanza areas and stuff, where there's a remote areas of mine. So we will engage today. Let me just start. So on the mining solution, so we're looking at three aspects. So one of the aspects we're talking about is your microgrid definition. We're also looking at distribution power system. We're also going to be looking at energy storage system. What is it? So if you look at the definition of microgrid, so I mean, you'll understand it's a group of interconnected loads and also distributed energy resources within clear, defined electrical boundaries. So you will understand that these actually operate either grid connected or off grid, so island mode. So looking at a distributed power system, we're looking at local consumption. So you will look at solar, natural gases, bioenergy, wind power, hydropower, hydrogen, you can name it, you know. But you can see there's no BESS on this because BESS on its own function as a load. So that's what we're actually introducing in a lot of mines currently because we understand that mines, a lot of them, they actually have probably two or three problems. One of the problems we're talking about weak grid areas where they are connected. Some of the problem also is your consumption usage of diesel generators. It's a lot, it's very high. So we're trying to also reduce that. And also in places like South Africa where they're using Megaflex under ESCOM. So they actually have fluctuating in terms of tariffs. So the tariff at this time probably is 3 rand. At this time is 4 rand or 5 rand. Is very high, and also it's seasonally also there's different. In winter and summer it's different. So the battery is coming in that way to actually help in the mining area. So looking at the PV ESS microgrid development, you will see that by looking at the rapid development of PV and ESS technologies, we're looking at the types of PV. We actually have a TOPCon that one is normally used in most of the projects. HJT is used probably most of your CNIs and your IBC also that is commonly used also. So we also have where's my cursor? We also have an energy storage technology facility. So on the energy storage facility, we're looking at probably a lot of cycles that you actually generate that day. You'll find out that probably at the mine, they actually talk about 2 cycles per day. Some mines where the grid is actually stable, like in South Africa, the coal mines probably, you'll find out they actually talk about 1 cycle per day because they want to correct the tariff issues that they have. So we also talk about high temperatures and resistance and also high efficiency. So combine these things that you're talking about, we've actually created a battery or we've matured a battery called grid forming. So there's a grid forming and grid following. Just to explain the two. Grid following is PQ mode. So PQ mode meaning that your battery is actually running on grid following. So whenever the grid goes down, your battery will also go down. So that's a grid following, or your PV will go down. So grid forming is when the battery goes down, then the battery will actually create something called VSG. So this is a VSG. So your PCS plus BESS will give you a VSG. So VSG mode is a virtual synchronized generator, meaning that the battery and combined with the PCS will create a virtual synchronized power. So synchronized power is your normal, if you do your electrical engineering, you'll understand the synchronized power is your grid power. Unsynchronized, there's a synchronized and there's an asynchronized. Unsynchronized is your alternative power, like your PV, your wind, your hydro, whatever. All those things that they don't have base load. Those are unsynchronized. The one with the base load, of which the grid, is synchronized. So the battery will create something called a virtual synchronized generator. So the grid will mimic the grid. So the grid will mimic it to feel like there is a grid, but there's no grid. So then the drop power on that, probably from PQ mode or from grid following to grid forming, will be 200 milliseconds in terms of the transition. So that's what we actually create in the mines. There's also other mines where we actually say there's no need for them to run on grid forming because the power there is very bad. So they can actually use a grid forming constantly. So this is a grid forming operation we actually have. Also, looking at the viability of a PV and ESS and microgrid business model, you will see that the payback period time of this is 3 to 5 years. Unfortunately, I can't show you. I've prepared also some of the presentation outside this, but it's a real project that we did in one of the mines in Mpumalanga, where we did a payback period of 2.10, 2 years and 10 months, just to actually prove that we're actually doing a short period of payback by using PV and ESS. If you're using ESS only, probably can do 2 years or 2 years, 10 years. But if you're using PV and ESS, you can do probably up to 5 years. And looking at also the levelized cost of energy by using PV, ESS, and a microgrid, you will save probably close to CNY of 1 per kilowatt hour versus the genset, the generator of the diesel. We all know that diesel is actually, the price is very high. So it will be 4 UN or RMB for Chinese kilowatt hour. So we also do virtual dispatching and control system technologies. So at Huawei, we also do the control technology for optimized dispatching. So where we actually have the master and the slave. So probably in a site where there is a grid like this one probably, or there's no grid, we actually have a slave or a master, probably is a power plant controller, and then the SACUs and the EMS, they become the slave. So it's a master slave control system that we have. And we also run end-to-end solution. So we give you inverters, we give you transformers, we give you PPC. We also give you batteries, PPC, power plant, sorry, PCS. We also give you transformers, and also we give you EMSs and grid form and MGCC, your microgrid controllers, central controllers. So looking at a typical microgrid topology. So we're looking at 3 sections. One section is intelligent power generation. So we have a power generation, power grid, booster, of which is your HV, and also we have your PV, your ESS, your wind, and also probably your SCP. So we also have intelligent control side, where you have your SCADA, you also have your EMS, you have your microgrid controller, you have your smart array controller, your smart meters, anything that does control level. So we're talking about this device level local response. And then we also have the last one, which is the intelligent power consumption. So this is a typical microgrid architecture that we actually have. So in this one, probably going to be focusing on the mine. So our load will be mine and probably also EV chargers, because we know at the mines, currently even the logistic is changing from the diesel logistic or the normal logistic that we know to EV logistics. So we also want to be looking at the EV charges on that. So benefits of the PV and ESS and microgrid. So we're looking at the availability on that, because we're talking about a VSG. So we told you that our battery can do 99% in availability, because it's actually modular. There's a lot on the battery. We can dive in one day on that. Today we have a short time to explain on our battery, but our battery, to quickly explain it, is fairly modular. Even our packs, they've got optimizers, meaning that if one pack is having a problem, you are able to actually continue with the operation and ignore that one on your BMS. So your BMS will ignore that pack and continue with operation. And also, if the SOC are not balanced, our SOC, our BMS will actually balance the SOC on the system itself. We also provide stability. So stability by seamless switching in case of power outages, improving production capacity. So this is actually done in places where there is probably there's no sensitive devices on site. So we do 200 milliseconds. But when there's a sensitive devices on site, so that's where we actually do power quality improvement. So we run it on a VSG mode, our battery. We also address the issues of ESG. So ESG being your environmental, social, and governance. So we reduce air pollution, we reduce carbon footprints, we increase green products, we also increase corporate reputation. So grid plus genset, you can see we actually reduce LCOE by 50%. Gas grid by gas turbine, we reduce by 30%, and we also do lifetime safety. So I've put a short story there. Patchwork solutions are difficult to deliver. High harmonics from inverter may cause microgrid breakdown. Inverter with poor adaptability to weak grids may be disconnected from the microgrid. Poor PV and ESS system may result in huge current flow to PCS of the load. What does this mean? It means that the patchwork, so patchwork, we're talking about you've got different products from different suppliers. So you will actually have probably on the higher requirements of stable operation of microgrid. So you will see that most of the time the system itself will actually to prevent circulation current. Probably you'll need something like your PV, your BESS, probably also generator in case if there's a power outage for a long time or there's no sun for a long time. And you see most of the disturbance probably occurs more than 10 times a year. That is caused by your storm, lightning strike, and the salty, misty in all those areas. And human also factors and also lines in defection. The lines, they also got defects. So the system power quality in that way will actually have a problem because you'll find high harmonics tolerance capability, and also you will find high harmonic output being easily caused disconnection of sensitive load. So these are the issues you have. So also looking at the PVSS as a difficult patchwork on the PVS grid, it's difficult to meet requirements for stable microgrid operation because you will find out that you've got actually different products in terms of inverters, batteries, PCSs, generator, load itself, and a power grid. So you'll find that you've got different products. So you'll find the MGCC will control interval seconds like this one. So it will control. So for genset, we are able to control up to a DeepC controller. And MGCC also will operate on a millisecond level or second level to control different power sources in that operation. PV inverter also, common inverter do not support milliseconds. And also ESS in the off-grid, we actually do VSG mode on that. So looking at the patchwork, the ESS vendor will be different, PCS will be different, transformer, inverter, and so on and so forth. So this will actually give you a lot of problems because if you've got a vendor A and a vendor B, and as a mine, you say the problem is sitting on vendor E as an inverter. So that means if a vendor E comes there and tells you that no, the problem is actually sitting on vendor C, a transformer, and a transformer comes, the guy from transformer vendor C comes and say, no, the problem is sitting on vendor A, a battery. So now you have a lost time, of which mines are very sensitive when it comes to time. So you need to actually make sure that when you buy, actually at least you buy end-to-end solution where you know that you want to deal with one vendor in these cases. So we actually try and avoid high safety risk, your low technical capabilities, your long commission periods, because if they do commissioning, different companies can actually take their own time, O&M difficulties when there's something like that. So this is a comparison of two cases. So we're looking at the central solution and also looking at the string solution. So you'll see that our string solution has very high heads in terms of switching on the IGBTs. So you can see we do 14 kilohertz to 18 kilohertz. And switching frequency range also on the central is 2 kilohertz to 6 kilohertz. So you will see those small spikes. Those small spikes can cause something called harmonic distortion. So harmonic distortion can be up to 2.29% for central, and also for us can be 0.728%, meaning that we actually less than on your line, we actually give you a smooth operation in terms of power quality. That's what the mines are actually looking for. Okay. So our inverter itself and PCS, you'll see that the short circuit ratio is 1.1, running at full power, compared to short circuit ratio of 1.15 tested within only 70% load compared to others. So this is Huawei this side, this is others this side. So Huawei at 1.1 short circuit ratio, we are able to do short circuit ratio current of 0.7. Also them, they can do that. We actually do 1% of the total harmonics. They can do up to 9.5%. We do active power not derated during high voltage right through. Here it's derated at high voltage right through. So you'll find out that your power or your inverter will derate when there's a high voltage right through on this side. So DC injection will be 0.5% on your PV side, and DC injection will be 11% on this side, meaning that we are also better on this. Huawei inverters itself have actually met the new grid requirements for Australia. We all know that Australia has got a very strict requirements when it comes to people who are connecting to their grid lines. So no one actually receives grid certificate, and probably there are 4 companies that have been selected to actually connect in Australia. And I will not mention all of them, but Huawei is one of them, meaning that we were able, and others that are also from Europe, manufacturers. So Huawei has actually proven that we actually can actually meet the grid compliance code for Australia on this. So last one. So just to check, just to give you the last on my slide before the references. So we actually support something we call PCS power in off-grid scenario. We actually say that it should be at least 1:1 in terms of the ratio. And others, they say probably PV to ESS ratio should be 2:1 in off-grid mode. But we actually say this because we understand that if it's 2:1, meaning that if there is a short circuit current that is happening or a reactive current that is happening on a PV side, meaning that your PCS will not be able to protect you, or probably your PCS will actually engage, will not be able to protect you because it will leave this thing open. And when it's open, that means all the short circuit will go to your load and then probably have problem in your load. But at Huawei, we say 1:1 because if the short circuit current or the reactive current is happening on the PV side, the PCS will then engage on the overcurrent protection trigger. So if that overcurrent protection trigger then is triggered, then you'll see the circuit breaker will actually open, or the isolator will open to protect the load on the side. So this is what Huawei we actually support in our side. Okay. Just few references before I close. Is one project that we did in Saudi Arabia is 1.3 gigawatts of microgrid. It's 400 megawatts of PV. The project is under Saudi Vision 2030. The project also had a problem because we actually look at Saudi as a small country that has got a lot of islands. So meaning that they have to do a lot of longer transition lines to the islands. So that will make their short circuit ratio very low because of the long transmission lines. So that's why they've requested us to give them a battery of a grid forming. So this is the first grid forming microgrid that we did in Saudi Arabia for them. So you can see customer benefits, grid friendly, and simply O&M, because our battery can actually do calibration of SOC automatically. and we also do multi-level safety protection. Kamoa. So Kamoa mine, we actually did a lot. We understand that in Kamoa, especially in DRC has got a power grid and a reliability or unstable. So the grid in there is actually very, very, very unstable. So they were using a lot of diesel. You can see there are diesel tankers on site. So they were using a lot of diesel to actually run the site. So what we actually helped them with, we actually did 581 megawatts, our best PV of 200 megawatts. The project currently is still under construction as we speak, so Q26 grid connection was supposed to be connected. So it's not the whole project that was connected. Some of the project, probably 20% of the project has been connected, or 30% has been connected. But you can see the customer benefit. They are saving a lot in 40 million US dollars electricity cost, and also on the carbon taxes, this is what they receive back from carbon taxes. PVNSS PPA model that we're doing there, we do a lot of, they appoint IPP, and then IPP, they actually fund their own projects on that. So that's how they actually do on the project. So PVNSS grid forming for stability, 30 megawatts of the load output. We do high reliability through 20 years of ESS file services on this. Mabende, also they were using a lot of power of diesel on this. This project is also in DRC, so they also had a issue of diesel usage, a lot of them. So we actually also helped them by 10 megawatts PV, sorry, 18 megawatts PV, 10 megawatt hour BESS. You can see the BESS is actually 1C, meaning that uh, the 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 outages are quite frequently. So you always have to charge your battery quickly 1 hour and wait for other outages on that. So that's how we did this project on benefits of the customers was to increase production capacity from 68% to 90%. Because they were using a lot of diesel. The diesel they were using probably 8,786 hours per day of diesel. Yeah, that we actually helped them. We also did iron mine in Algeria. So they also did their first microgrid energy storage for Algeria for this one. So reliability also on this was 100% renewable energy safety. And also we did a black start because they've got quite a lot of outages on that side. Second to last is MMG. This one is quite a famous project that has been done in Liberia. So we also know that Liberia's got a weak grid. So most of the mines, they actually suffer the weak grid penetration that is happening. So we also help them with the 100 megawatts our best, cost-effective genset PV and ESS, reliability, fast grid connection on this one. Okay, guys. Thank you. I hope I was not that long, Salim. I think I
You
did.
you really played the game of the timing. I really appreciate that, and I
Thank
would
you,
have
Salim.
even give you 1 more minute to add more slide if you head back. It was very amazing, especially backing up the presentation with the case study. I think this also gives the audience an idea of what you are presenting. Now we will jump with Jaluka, who also has a very amazing presentation. And right after Jaluka, we will have a Q&A. So once again, I advise you to use the Q&A for questions. Jaluka, Jele, it's your time to amaze us with your presentation as well. Thank you very much.
Thanks, Salim. Hi, guys. For everyone who's joining on the call, I'm Jaluka Jele, based in South Africa, representing Huawei Digital Power Sub-Saharan African version of it. And then what we focus on for now, I'll be going through a bit of what Sandile has shared so far. In it, we have 35% of my presentation will be focused on our products. However, 65% it will be focused on the market insights. So the title for my presentation is From Capacity to Fame, Intelligent Power, and how the market signals are shaping the next phase of the Africa solar economy and the technologies required to basically scale as we are going through it. Colleagues, please mind you, we're not that familiar with Zoom, some of us, so it might be a bit sluggish. The thesis that I will be offering throughout this presentation is the fact that from the solar conversion in Africa, how it's basically moving. So basically from your capacities, your economics, your reliability, and your firm power, right? How many megawatts are we pushing for from our side? That is crucial for us. The economics, how much energy cost can be avoided for our partners. That is what we are focused on. The reliability, can we keep the business running? Meaning for most of the partners that we are working with, they need the operations to continue running, and we offer specifically those solutions. The firm power, can renewables behave like infrastructure, of which we are seeing the adaptation of renewables such that they form part of the asset class for our partners. Being titled the fact that the winning proposition is no longer just cheap solar. We need to offer, and we are offering, the reliability, dispatchable, safe, and optimized electricity over the asset life. As our president, Mr. Shai, has said, from us as Huawei Digital Power, specifically the Sub-Saharan African version of it, we are highly focused on the company reliability, technology reliability, solution reliability, product reliability, service reliability, and lastly, operational reliability. So when you benchmark us as Huawei Digital Power, please benchmark us as based off of all these 6 components relative to our competitors and also the different suppliers across the market. The executive snapshot from the market when we are looking at our signal that defines the 2026 market, we have 4 main components. You have your acceleration, your storage, unlock, your grid constraints, and lastly, your life cycle value. For acceleration, we have Africa has reached the record solar edition in 2025. The momentum is broadening beyond the historic leaders, meaning from the last year, we have seen the highest level of energy penetration or renewable energy penetration. The storage that gets to unlock the potential. We have falling storage costs that have changed the business cases from energy savings to backup, time of use applications, your peak shaving, and diesel displacement for our partners. The grid constraints, weak grids and high renewable penetration increase the value of grid forming, frequency support, black start, and controllable outputs, of which our products, particularly for the microgrids, are focused exactly at that. However, our key focus is the life cycle value, of which offers the safety, O&M, availability, degradation, and digital control, increasingly that decide the bankability of our projects. And not only necessarily the capex of a project would be the only benchmark or the limiting factor that would be utilized for the projects. The market is becoming more technical and more financial at the same time. So what we are seeing as a market signal based off of the scale from 2025 was the tipping point when Africa saw its fastest solar deployment year-on-year record. We have seen 4.5 gigawatts of new solar installation in 2025 as per the Global Solar Council estimates. That is indicative of 54% year-on-year growth that we have seen versus 2024. The countries that have added over 100 megawatts of renewable resources There are at least 8 across the Sub-Saharan, across the African market, 90% of which share the top 10 share of the editions. Why this matters? The deployment acceleration is now measurable, not necessarily a theoretical approach. The next bottleneck then shifts from the modules to grids, storage, finance, and executive qualities. The fast growth amplifies the cost of weak commissioning and poor lifecycle support, of which with ourselves as Huawei Digital Power, we refer to ourselves as a localized OEM, such that for every country we have representatives, we have direct contacts, we also have direct links such that you can operate an interface with us directly as an OEM, right? This is from a message in terms of now the AFSIA. Africa has moved from a level of promises to execution risks, right? In terms of now the scale that is uneven and the leading growth based off of the maps that are shifting, the new edition are increasingly spreading across more of the markets, but not necessarily, however, the top countries are still dominant, and commissioning value is also being recognized there. For South Africa, it's leading the rest of the African market. We are seeing 1.78 gigawatts of deployment, at least that has been deployed, followed by Egypt at 0.71, Zambia at 0.31, Nigeria at 0.25, of which we are anticipating that we are forecasting that Nigeria would most likely be the one that will grow the most if certain bottlenecks are addressed. Angola at 0.22. The insights is the fact that for solar volume, it's a scale, but not yet an even one. So the strong markets still need reliability and integration depth. Emerging markets need the standardized replication. Emerging by referencing, we have different tiers of the countries that we are focused on, with emerging markets that need that stabilization, replication, and bankable delivery models. While Huawei SSA can add value across the different countries due to the cross-country solution repeatability, that matters because of the SSA projects. This face the similar, our customers, they face the similar pain points as per the grid instabilities, the fuel cost, the site heat, the limited O&M capacity, and the execution risks. From the customer values that we are offering, the installed capacity doesn't necessarily answer what customers really pay for. What is it that customers do buy? They buy the lower cost, the fewer outages, reduce the diesel dependency, power quality, predictable OPEX, and the climate credibility. Which assets must we deliver? The kilowatt hours at the right time, peak reduction, reserve capacity, stable voltage and frequency, controlled export imports that are done in accordance. What financials are measuring us on is the availability degradation, contracted savings, operational proof, maintenance risk, and the insurance and safety profile. For AFSIA's angle, the solar is no longer sold as equipment; it is sold as a managed energy outcome. The best signal, the economics of generation availability are now a storage conversion. 80% higher, over 80% of battery prices. Battery prices have declined by over 80% since 2013. This is on the utility scale. Battery packs, in terms of dollar pricing, you're looking at $115 per kilowatt hours as of 2020. For averaging as per the Bloomberg NEF estimates, 4 hours of common duration references, of which is what customers are looking for. in terms of their capacity and energy value. Why it matters? At lower storage cost, the value case expands beyond the backup, time of use arbitrage, demand management, diesel displacement, RAM control, export shaping, and resilience are the reasons why it matters. The message for SSA, many African CNI customers already pay a hidden premium through outages, generator fuel, production losses, and poor power quality. Storage that gets to be monetized then would allow them to avoid this level of headache. For the CNI, of which CNI forms part of the microgrid to a large extent in Africa, you can think of it as mini microgrids, basically. CNI is where Africa's solar and BESS economics, they become a lot more concrete. With industrial tariffs, the high daytime energy use makes PV valuable as an immediate resource for Africa. Diesel exposure, the fuel and maintenance savings that create strong storage backups. There's still a major bottleneck. The outage cost leading to lost production often exceeds the electricity bill. Also, as a result, the fast deployment of these renewable resources behind the meter projects, they avoid the long utility development. Hence why the small microgrids are effectively being deployed. The CNI then buyers do not necessarily need an academic decarbonization pitch. They need a business case that reduces power risk, fuel cost, and operational downtime. The present PV plus BESS in money terms, the avoided kilowatt hours, avoided KVA, avoided diesel liters, avoided production losses. Then add life cycle risk. You have your safety, monitoring, warranty, maintenance, and controllability of the plants. On the diesel displacement side, of which is not necessarily a backup story, it is an operating cost for our partners, such as your fuel. It reduces the liters of consumption. Your runtime will reduce the generation hours. From a maintenance perspective, you reduce the service and intervals and also the failures. For quality reasons, you stabilize the voltage and frequency as well as the transition of the grid. What to show customers? Quantify the diesel baseline first in liters per month, generator hours, your load profiles, your outage patterns, service costs, and production losses that are being exposed. And then we show the PV and ESS savings for our customers, such that they can have an understanding as to how we can de-risk the reliance on diesel on DGs. With Huawei relevance, the control coordination between your PV ESS grid, genset is where a design becomes a reliable plant instead of necessarily being a separate equipment. For BESS, your ROI logic in terms of now the economics that must be application specific. You have your self-consumption where we use the PV on-site value as we drive for on-site. The value driver, you have energy saving. For time of use shifting, you have your charge low and then your discharge at the higher level. The value driver, you have your tariff that then gets spread out. This can also be used for relatively most of the markets. The peak shaving, you have limited maximum demand. Value driver, you have your demand charge. For backup reasons, we keep the critical loads on. The value driver being the fact that the outage cost is then lower. Diesel saving, you reduce the genset fuel runtime such that the value driver becomes then your fuel and O&M, of which we know that for DGs, the cost is high. Grid support stabilizes the plant and grid with a value driver of availability and services. We do not sell a battery, we sell the highest value use case and control strategies for our customers. The grid quality, we grids make the control capability a bankability issue. So you have your grid following limitations. Traditional inverters rely on a strong grid voltage and frequency reference. We grids then exposed stability issues, the nuance trips, and then power quality risk. For grid forming value, grid forming assets can then create voltage frequencies, references, and inertias, black start and control islanding, of which are some of our key features that we offer, particularly for the DG side, also for in terms of our best sites. The SSA impact is that when it comes to the mines, the islands, industrial parks, remote loads, and weak distribution networks, they always consistently need power systems behavior, not only energy protection. We ask when it comes to the grid strength, the fault level generator, minimum loading that needs to be met, the critical loads, transition modes, and protection philosophy. You have also the design control hierarchy before the equipment procurement. Safety, which is one of our key selling point, must become a procurement and a finance filter. So from ourselves, we offer the best chemistry, the quality, and the highest level of monitoring for the cells in terms of the packs. We offer the thermal part and the sensing capabilities there. From a rack level, we can isolate and contain any issues that may be presented there. Your container and systems, you have the fire strategy, EMS, ventilation, and lastly, your layout. Life cycle, we have your O&M and updates. Lastly, the traceability across the value chain and across the multiple sites, blah, blah, blah. Yeah. The core point is that when it comes to best, safety cannot be necessarily evaluated only at a cell level. We have to have the procurement that must be examined from a system level, prevention, detection, isolation, suppression, operation, and after sales support. Why safety incidents affect insurances, permitting, customers, trust, and financing appetite. The digital O&M that separates the bankable fleets from the standard assets from an operational standing point. You have your commissioning, you have operations, and lastly, there's life cycles. So due to commissioning, you have to be focused on the parameter discipline, the CT meter positioning, your POI logic, your export controls, and protection checks. On your operations, you ensure that the remote diagnostics, alarms, availability tracking, SOC, SOH, visibility and dispatch optimization are done in accordance from a lifecycle perspective. You have degradation tracking, performance verification, maintenance, prioritization, and fleet benchmarking. For distribution and CNI fleets, the dashboard is not a nice to have. It is the operational control. This is on your O&M side. EPCs win repeat business when they can prove performance after handover. Owners then, when it comes to their finances, better when the assets are having a higher availability and savings are visible.
Sorry, Jelly, I would advise you to wrap up a little bit due to timing, since you are heading to the questions.
Yes. Let me see. I was going to go for some time.
Yes.
Okay. I will close with this slide then. So when it comes to the system integration, integration, your design requirements are key, such that you have your PV generation, ESS, energy and power, your grid imports and exports are done in are relatively met. Your genset, you have your backup and support loads, you have priority flexibility, EMS, which is one that we are offering the most. You have the controlled hierarchy for them. So for design risks, we have to reduce the poor what's this thing, interoperability of them. I will close here and hand back to Salim.
All right, so I will request both of you to turn on your camera. So Senela, you can also join me for this interactive session whereby we will address as many as questions that we can from the audience. Sanile, can you turn on your camera and your microphone as well?
Still here.
Okay, this is perfect. This is very nice. So moving up to the Q&A, I would like also to remind our participants to now move to the question side. We've been receiving many questions, and I would like to start the first one from the mining solution that Sanele, you have just shared with us. Since this environment is very particular to other type of CNI, we would like to understand what makes this mining environment particularly challenging for PV and storage.
Okay.
Sanele, did you get me?
I get your question.
Yes.
Okay, so by looking at mining environments, particularly challenging for your integrating of your PV, probably also, and your ESS. So because of the electrical load, Salim, so you'll find physical environment and also operational requirements are very different from a typical commercial or utility installation. So I'll give you an example probably of key challenges. There's a lot of them, probably more than 10, but I will give you some few key challenges. One key challenge I will talk about is your variable and higher power loads, and also your inductive loads. So you'll find that your mine has got a lot of motors. Your mine actually has got a lot of mills and also crushers, conveyor belts, conveyors. There's a lot. So that's one key challenge for this. Actually, you'll find probably on these things, the inductive loads. If they are inductive loads, of course, rest assured, you'll find inrush currents, voltage dips, frequency disturbance. So there's a lot of things that are happening on high variable and also high power loads. So another challenge also is that the operation should be continuous, 24/7. So any disturbance can extremely cause expensively, for your mine. So you need to actually make sure that you always keep the stability and sustainability on the mine. Just a few examples before I continue to key challenges. We actually went, I'm actually currently right now I'm in Tanzania for work trip. So we went to the mine in one of the mines in Tanzania. So we find these challenges, actually, they're quite common globally, or maybe let me say continentally in Africa. Wherever I've been, in South Africa, in Tanzania, in Ghana, in Liberia, where there are mines, I find these challenges, they're actually the same, where we actually have also one of the challenges, the third one probably, we're talking about your weak grid and also isolated grids. So most of the mines are actually built in places where they are actually quite far from communities. And you find that the grid operator, which is Eskom or ZESCO or TANESCO or whoever, is having difficulties to actually reach the mines because they're actually very far. So you'll find out that where they've actually put the substation for that mine, it's the last bit of the grid operator. So you'll find that substation will have a lot of problems and harmonics and all those things. So that's why you find out that most of the mines, when they're still mining, but they actually have dips and everything because of the weak grids they actually have. We also have something like your harsh environments in those mines where they've got high dust. Some mines they actually deal with coal, so there's a high dust in that, extreme temperatures and stuff. We actually have probably large distance in terms of the difficulties of logistics. There's a lot. I'm not going to mention everything, but power quality is one of the major ones where you actually have your harmonic distortion, reactive power, voltage stabilities, probably also power factor correction issues. So those are the things that we're actually talking about when we're talking about at least the mining environments and particular challenges they actually integrate for the mines. So yeah, I think I've answered that question.
Yeah, I think you've answered the question, but I might have missed to make it more solution solving in a way that yes, we have understood the challenges that you've just highlighted here, but I believe you are here to bring the solution, and I believe this is what you presented. So just shortly, how is Huawei tackling solving those challenges that you have just mentioned very shortly before we move to JD?
Okay, so Huawei is actually then on that issue that you're talking about, on all these challenges. We've actually developed a lot of technologies at Huawei, even with CNI. I know Jared CNI also is working very hard on a CNI. So even on microgrids, the small mini microgrids is talking about, we've actually come up with these technologies like your grid forming. So grid forming, we believe for mines, for microgrids, for mini microgrids, for hybrid systems, grid forming on our ESS will actually solve quite a lot of these challenges because we're talking about ESS sizing probably, you know. So in the ESS sizing, we actually do peak shaving, we do time of use, we do um, backup system, we do maximum self-consumption, we do a lot with our battery. So any challenge that you might have, we also save diesel integration that you actually have on that site. On the site, some other site, they actually go black start. So we also have black start capabilities on our batteries to solve those issues. Some other site on their on their grid, they actually have inertias on their lines. We also solve those inertia responses on that with our battery. So our battery, as Huawei, we've actually put it there on the market and also in the community to actually look at it and explore to see the technology that we have on grid forming and actually the capabilities of grid forming that we have. We actually have 6 core capabilities of it, the big start and all those ones that I've been mentioning. So that's what Huawei does on that. And we actually have developed a new PV inverter. You know that inverters, they've been grid following and also grid supporting the one that we had, grid 30. But the new inverter that we have currently is a 506 kilowatts. That's a grid forming inverter. So the inverter itself can run without a grid now these days. So our inverter can run for 20 plus years without a grid. Just the sun shining on a PV solar, then the inverter actually run on a VSG mode. We create our own grid on that. By virtual synchronous generator, we create our own grid to actually start the inverter. So these are the things we actually do. Thank you.
Perfect. Jelly, I would also just advise you to be very brief in the answer. Coming back to you, it's very great that we are having this conversation because overall, the Africa Solar conversation is really moving beyond simply asking how many megawatts can we install. So it's moving from this conversation to world reliability and farm power. So what is driving the shifts of that conversation, and what does farm power actually mean for the African business and industry?
I'm not sure if I got the gist of your question. Do you mind repeating just the last part?
Yeah, so I was just saying about how the conversation in the industry has moved from how many megawatt can we install to reliability and farm power. That's why we
Or
wanted to
reliability.
understand. Yeah, so that's why we
Okay.
wanted to understand what is driving the shift and what
Yeah.
does farm power actually mean for the African business and industry.
Okay. So to the short answer is Africa needs more DERs than what's this thing, than just any other product. And hence why we, like in typical markets, you'd find as a tier one OEM, you won't necessarily be the front line since you have all these other products that could easily be adopted. However, Africa needs the tier one. Why? Most likely it is going to adopt the venture into DRs, particularly from DRs, we are most likely going to experience the VPP version since the main bottlenecks for Africa, the fact that there is just no energy. So from a distribution point of view, there are also those constraints, you have transmission issues, so on and so forth. So to overcome all of those things, the DRs then become the main answer. And hence why reliability then and resilience basically then become the frontliners for the adaptation.
Perfect. I think I'm picking this question from the audience. This question is from Natasha, who is watching us, and I believe it can be addressed to both of you, but we'll move with Sanele. Natasha is asking, many rural community in Zambia is still lacking reliable electricity. So how can Huawei smart microgrid solution be implemented through public-private partnership to support productive uses such as irrigation, agro-processing, healthcare, school, and small-scale mining? I believe, Sanele, you can pick this question, I mean.
Salim, this question is actually based to Jele, but it's okay. I'll answer it.
Okay,
Um,
we can still move it to
it's
Jele.
okay.
No
It's
problem.
okay. It's
Okay.
okay. Okay. Look, I just gave you some few examples, also what Jele has also discussed with you, Natasha, and also Salim. One of the things that Huawei is actually very passionate with, especially also, I'll just make an example, just a few examples. There's a company called REA, REA, I think it's in REA, it's in Nigeria.
Right. It's a
Uh,
rural electrification agency in Nigeria.
exactly. We are working
Yes.
very close with that company. We're doing a lot of mini grids with them. We understand that Africa is actually one of the crises in Africa that we have after water, because water is one of our crises, but after water is also energy. So we have actually pulled a lot of mini grids with that company, and we will actually want to expand it also. Even in Malawi, we are doing a lot of mini grids as we speak currently in Malawi. We will actually like to also expand it. If Natasha probably has your contact, Salim, she can actually send her details and look at also that company or whatever that place there is. We will look at the rear of that place. We will actually try uh, we'll try and collaborate with them to actually do the expansion of electricity usages on those areas. So, truly speaking, we actually do a lot on mini grids using our BESS. We're using also our CNI inverters like your Sun 2150 kilowatts. We've got a new battery 241 now. We can actually do a lot. Well, there are areas where they are very big, where we actually can use our 5 megawatts, our burst, or we use our 6.2 of our burst that we actually have. The nice thing about the 6.2 megawatts, our burst, is because the transition between the PQ mode to grid forming is actually very less, probably around 40 milliseconds, no longer 200 milliseconds. So we actually do a lot on that. I think I will have to end it there. But if Natasha has got your details, please, by all means, Natasha, if you're listening, please send all your details to Salim. Mr. Jailer will actually take a look at that and also contact and connect with the
All right.
RIA, Rural
All right.
Electrification Agency.
Thank you, Sanile. But since you've already mentioned that Jelle can respond to it, maybe if there is anything that you can add on, Jelle, or if we can move to the next question.
I think we can move to the next question.
Perfect. So there is a question here coming from Paul asking, and I think it's a very, very interesting question. A very big challenge is that we are facing here in the African continent. It's really all about the transfer of technology and transfer of knowledge. So beyond supplying technology, does Huawei have plans to support local manufacturing, technology transfer, and training from Zambia engineer, EPC contractor, and university to build local capacity in deploying and maintaining fusion solar and base solutions? Jile, I think you can jump.
Sure. Now that is one heck of a question. It's like it is that long of an answer. However, trying to keep it short, there's this thing of localization, right? Specifically, say in South Africa, where there are specific requirements of which OEMs have to meet, and there are specific ways that we are localizing such that we can empower local manufacturing. However, as an OEM, since now these products that we are selling are finished products, they don't necessarily localize such that they can ensure that manufacturing happens local. Why? I'm sure you'd know from whether you are referring to a PV inverter or a BESS or any of our components, you're looking at a supply or a value chain that needs multiple countries. So even for China, of which we're a Chinese OEM, we are not necessarily sourcing all our resources or components such that we can build these units only from China. So the whole value chain needs to be driven such that we end up with a finished product. So the same would most likely happen even for Africa. However, the localization that I am personally witnessing and I am responsible for is stuff like the enablement, ensuring that we train our partners, we enable our partners such that they can understand as to the technical aspect, the applications, the different applications here and there. However, from a manufacturing standpoint, of which it would take much longer, those are not the sort of manufacturing capabilities that we are seeing localized. What we are seeing, though, is the fact that from the PV manufacturers, those are the ones that are more transitioning into a localized manufacturing based. I have also seen one of our key competitors. They have now started an implementation phase of a manufacturing plant up north in Africa, not necessarily in the Sub-Saharan African market, to basically cover the North African market as well as parts of Europe and the East there. So yeah, that's what we are seeing. So far, only one of our competitors has managed to actually build an actual plant in Africa.
All right. And moving to the next question from Olo Mat. Yes, Sanile.
Salim, sorry, just to add on what Jelle was,
Yes.
because I saw this question from the question, and I was interested in answering this question because, really speaking, if you're asking the guy, I think he was asking about beyond supplying technology, does Huawei have plans to support local? Yes, the answer is yes. I think Jelle has answered it quite very well. But I would like to distinguish between what Huawei has already publicly demonstrated and what will need to be formally committed for Zambia itself as a country. So you will understand that Jelle spoke about the enablement and certification model or mode of what Jelle does. It actually does a lot of partner enablements in terms of trainings. So for people who wants to do pre-sales and stuff, but also Huawei is also doing a certified service partners. We call it a CSP. So CSP is actually certifying the partners that they want to do installation and all those things. So it's a deployment of O&M services. So we also have a program that was launched by Huawei a couple of years ago. We call it 1,000 Digital Power Talents Program. 1,000 Digital Power Talents Program. The program was aimed to upskill up to 1,000 solar installers or practitioners, whatever, installers in Sub-Saharan. So this program is actually still existing as we speak currently. But also, what Zambia can do, go further, is to also maybe I think opportunity should be local capability development, you know. So probably we're looking at doing also what we call maybe a Huawei or Huawei Zambia program that we can actually do maybe going forward is to train engineers from Zimbabwe on PV design, best sizing. There's a lot to actually do, SCADA communication, PCS, whatever that you can think of. So we actually do probably some 4 levels. So we do installation, we do commissioning, we do advanced troubleshooting. We also do microgrid PCS, PPC, and PCS, ESS integration. So this will actually help us to also maximize our strength and also maximize our opportunities in a certain country. Not Zambia only. It could be other countries. It could be countries like Tanzania, where I am. It could be Nigeria. So these are the things that Huawei actually, when I'm talking about 1,000 Digital Power Talents program, was aimed to do something like that, to upskill people to know how to deal with Huawei. But of course, you're not going to lock them to do Huawei only, but we would like them to actually understand our product and do our product through the training that Jelly does, of which is a partner enablement certificate model, and also probably also the certified service partner that's done by service department. So these are the things that we actually want to do. Can't remember who's this Mr. who asked this question, but the question was very nice. Thank you.
You're welcome. You are very correct on this, Sanele. And just because I've seen Nicole asking the same question in the Q&A, also in the chat, I feel like it might be incomplete, but you will let me know if it's really correct on your side. She's asking what are the capex implicated and what type of financing. I think she should have, this really depend on the projects, but maybe you might have some words to say about this question. She just asked what are the capex implicated and what type of financing. But I feel like the question is missing. But I don't know if it's correct on your side.
So if maybe I can jump in there. When it comes to Huawei, how we operate, you can we are an OEM, right? And the reason that from my side I have skipped over that part is the fact that as an OEM, the financing model is mainly the responsibility of our partners. Right. So as an OEM, we supply, so it could be for the EPCs, the developers, so on and so forth. However, the financing model then differs, of which you have highlighted so far as to for Zambia, what is the specific financial model that would be used. However, from our side, since we are not the front runners for a project, we don't necessarily step into that domain.
All right. And another question here from Olo Matlala. She's asking, what about the hot swappable battery and rack from Huawei? Yes, Jele, you can proceed.
Okay. With those ones, we refer to them as augmentation on our side. So with our batteries, in the main, we encourage our partners to use our batteries. However, even with the different generations of our ESSs, you can use the previous batteries with the current ones, and even the current ones with the future current versions, basically. So yes, we do support battery augmentation.
All right. Stanley, The presentation that you just did highlights the limitation of patchwork solution using equipment from multiple vendors. From your experience, what are the biggest technical and operation risk of combining different PV, ESS, and PCS and control system from different vendor?
Absolutely. Thank you. So in a mining microgrid, for example, the biggest problem with the patchwork architecture is not that the individual PV, probably inverter, BESS, PCS, PPC, whatever, EMS, whatever it is there. The problem, the system is necessary power, but the problem with the system level may not have probably the single owner. That's the problem we actually have. So this becomes particularly seriously when you actually have multiple vendors controlling the same power in that area. So like your voltage, frequency, and operating modes. So the biggest technical risk we actually have in this actually is actually your control loop in conflict. So probably that is your risk, maybe your highest risk in that, your control loop. So you can have probably your EMS, PPC, PV inverter, or EMS BESS controller, and also PPC BESS, whatever. So if two controllers are trying to regulate the same parameter, they can fight each other. We know that we've seen that with probably in one plant, you've got probably vendor A and Huawei or vendor B. So if ever there's a problem on this one, you will call these people, but these people will try and also hide and themselves and say probably no, the problem is coming from this one because they also want to have time to fix their issue. So, for example, you find your PPC request the best to increase active power, because the PPC will actually control as a master. So it will ask to control the best to increase the active power to stabilize frequency, while the best is on controller is responding to COC, to SOS, what you call SOC, your state of charge. So the frequency and DC limits will actually also have some issues on this in those particular issues. So really, in a hierarchy of any fault, no one really owns the control. So when there's a problem of a plant grid controller, it will actually blame it on a PPC or EMS. PPC will blame it on a PCS or PV inverter or battery or PV field. So we actually need to have an end-to-end controller. When we're talking about an end-to-end, end-to-end supplier. So we're talking about probably your master controller. So the frequency control, voltage control, reactive power, islanding, black start, your curtailment, if there's a curtailment in that site, your best associate reserve. So these are the things that you actually need to actually be controlling in a project. So the patchwork is very difficult to actually do that because a certain portion is actually owned by other people, a certain portion is also owned by other people. At the end, we are running a mine here, Salim. If you are running a mine, the thing that you don't want to lose is time. Time in the
Definitely.
mine is everything. So if time in the mine is everything, choose one supplier so that everything that you fall into and the problem that you have, talk to that supplier, it will actually serve you. But if you've got 5 suppliers on site, even commissioning that site, even if the site was supposed to be commissioned within 3 or 4 weeks, the site will take 3 or 4 months because everyone is doing their part. We're trying to integrate. So that's a problem of the patchwork we're talking about. I think
Perfect.
I've answered that question.
Perfect. And Jelly, this is the last question that I will ask to you, and then I have one question for the both of you. The battery storage is has been increasingly being used more for backup, and we would like to understand how should African CNI customer think about the different value stream of BESS, such as the peak shaving, the TOU shifting, the diesel displacement, and backup. How do they determine which application give them the strongest return on investments. This is really a business case for BESS.
Yes. I wish there was a short answer, Salim. However, the shortest
I
answer I
give
can offer you for that would be the fact that it needs to be project specific. So we as Huawei, we don't necessarily go like, okay, these customers, this is the solution that we'll be using. So depending on the requirements, whether you're looking for time of use, we use the ESS such that it meets that for our customers, right? If you're looking for peak shaving, we do exactly that. If you're looking for ancillary services also, in addition to that, we do that. Generation expansion, we do exactly that. SOC management, right, such that you can do what's this thing, the ancillary services or also the PV curtailment, we can do exactly that. So depending on the sort of pain points, again, from a customer's side of view, it's then that we deploy a solution that is best fit for their requirements. I hope that answers your question, even though I'm twisting it so much.
I think you just did it well. And one last question before we close this amazing discussion that I'm seeing the audience really active in question both in the chat and the Q&A. One take home, like what would you advise our participants to take home as a lesson from this presentation? The same question that I'm addressing to Sanele, I'm also addressing it to you, Jele.
Let me take it off. Let me start from my side. The key takeaway from my message is the fact that from an Africa's perspective, is the fact that Africa is dealing with energy poverty. We have a different issue as relative to the rest of the world, in particular relative to the developed markets. So we have seen from a graphical representation or the stats that have been presented, especially from the Western world, of that their consumption has been flatlining. However, with Africa, we have energy poverty, meaning we don't have any energy at all. At the same time, we are faced with a new wave of issues such as AI that is increasingly going to need additional capacity. So Africa is looking upwards when it comes to consumption. The bottlenecks are maybe the upstream ones, but however, from a product standpoint, we are here as Huawei to supply the African market with the best batteries in the world.
Senele, one take home from your presentation. You can unmute your microphone, Senele.
Okay, sorry about that. Look, for me, the key takeaway is that the grid forming should be viewed as the power quality and also energy security asset, not simple as a battery or storing solar energy. You know, people, they look at the battery, when they look at the battery sitting there, they see something that is just storing power and stuff. No, the battery has actually more to offer in this market, especially in the mining and also in other microgrids and whatever that you can think of, even in utilities. You know, we've got utilities that are actually very weak, like EDM in Mozambique. They actually also have a problem of weaker grids. We also have a snack from Angola. We actually also have a problem on that, where we actually have power quality issues on the utility side now, not just on the mining side. So grid forming should be viewed probably as a power quality and also energy security asset. So for mining, probably we can look at probably maybe 5 things around that. So one of them will be to stabilize a weak or unreliable grid. We also do protect production from disturbance. We also do the improved power quality. So probably talking about voltage support, frequency regulation, reactive power support. power factor improvement, your fast effective power response, your renewable energy smoothing, your support during motor load and transient in the mining. There's a lot that I can count under improved power quality. We also talk about enable higher PV penetration. So because of the PV low cost of energy, uh, compared to your diesel and everything that you actually have, the PV price, if you're looking at tracking back, Salim, probably 10 years ago, it used to be very high. Now you can find a PV probably at 8 cents, a watt. So this is actually something that mines and also utilities and also IPPs should be actually benefiting on. And also the BECS itself, our BECS is actually very flexible and also stability wise. So maybe number 5, we can talk about probably reducing dependence of a diesel, So removing diesel on this, and we're not saying that your expensive generator, take it and throw it away. No, we're not saying that. We're saying that keep it, but integrate it with your BESS and the PV. So during the day, you run PV. After the day, when the radiant is low, you run the BESS. So if the BESS is actually very low and it cannot be charged because the PV is still waiting for the sun, you can use a generator for those 2 hours or 3 hours, whatever. So that's what we're actually talking about. So these are the takeaways that I'm actually giving you on this for me. So probably I can talk about low diesel consumption, high renewable penetration, and battery voltage compatibility.
We would
Yes, sir.
we would really love you to talk about this, and I would really love to invite you for our next webinar. But for the sake of time, one last word. There are some people who are asking for your contacts. I'm just having Osaze here, who is a mini-grid developer in Nigeria, who wants to purchase inverter and battery, but he's still routed through a distributor and he need the best price. And I'm seeing those kind of requests from getting in touch with you. Definitely, we will share with you Huawei the contact, and they will follow up with you. I would like also to close the webinar, but before doing so, thank you very much from Huawei team, from Sanile and Jele for this amazing presentation. As you can see, it was very exciting, even from the audience with the questions. And also thank to our participants for joining us actively and massively from Zoom. But we are also live streaming this webinar across different channels on YouTube as well. Thank you very much. I am going to close this webinar, and I look forward to have another amazing conversation with the Huawei team for any next webinar or conferences. Thank you very much.
Thanks, everyone.
Thank you, guys. Thank you. Thank you so much. Enjoy your weekends.
Bye-bye.